Hello students, myself Rahul Kotkar. In this lecture, we are going to discuss about the chapter Magnetic Fields Due to Electric Current. It's our lecture number 6. Which topic we have to study in this lecture? That is simple, 10.12 Magnetic Field produced by a current in a circular arc of a wire. So, first thing, what is the arc? Okay, arc means simply what is that? It is a part of circle. Okay, as you know, the part of the circle is called as a arc. Okay, this is also the arc. You studied your mathematics. Okay, so what is that? We have to find. If suppose we consider this is the radius of the circle, okay, and as it is a radius of a circle, this is a center. Okay, let's suppose that is a O, this is a point A, this is a point B, okay, and this is a center point O, this is the radius and this is the angle form. And so we just talking about this upper part of arc AB. Okay, now in this case what we consider that a current in a circular arc of a wire. Okay, let's suppose which looks like this. As I show the figure, it's a part of circle. This is your A to B is the arc of that given name of that given arc. Let I be the current flowing through this arc. Now, as from this, what we can say, this is the center point O, this is angle theta. Okay, now to find the value of magnetic field produced by a current in a circular arc of a wire, what we have to consider? We have to consider that, okay, basically what we have to find? The magnetic field produced, okay, at point O. Magnetic field produced at point O due to a current flowing in a circular arc of a wire having radius r, that's a part of circle. Okay, means it is a part of a circle and that circle having radius r. Okay, that circle having radius r. Okay, and for that particular arc AB, if the current flowing through that arc AB, then what is the value of magnetic field produced at this point O, means at the center of the given circle. And so how we can find it? So for that we know the Bioware Cyber Law. As according to that Bioware Cyber Law, in a vector form, it should be noted as a mu 0 divided by 4 pi I into dl cross r, okay, divided by r cube. It's simply the vector form, but as you resolve it or in magnitude form, you can simply write dB is equals to mu 0 divided by 4 pi I dl sine theta divided by r square. Okay, so how it should become, friend? It's a simple one. Okay, you take a cross product of this one. What is that? It is the cross product, and so it is a dl r sine theta. Okay, you know that a bar cross b bar can be written as a ab sine theta. Okay, and here what is that? Simple dl, okay, as well as r bar, okay, means r, okay, and that r1 here and this remaining r get cancelled, and so here only the square will be remain. Okay, and so we directly write the formula for this one. That is a means no need to write the vector form. You can simply write, just consider that, make a consideration of this one. Consider a arc AB, okay, which is the part of a circle having radius r and center O. Okay, then note there what is the current flowing through the given arc is I, and For finding the magnetic field at the center point O of a given arc, let we use the Bioware Cyber Law. The magnitude of the magnetic field at a point O can be given by dB is equals to mu 0 divided by 4 pi I into dl sine theta divided by r square. Okay, then to determine the magnetic field due to this arc, first we will divide the given arc into the small number of small elements of length. Okay, means we are distributing it into the small parts of length dl each. Okay, so dl, and combinedly you can write sum over, or you may write integral of dl, which will gives you the total length of this arc. Okay, and so as per the formula we can write here dB is equals to mu 0 upon 4 pi I into dl sine theta divided by r square. Now as per this, okay, we divide it into the small number of pieces. Okay, so we consider one such a piece of length of element small dl. Okay, and this is the direction of flow of current. Now as per this one, what we can say, the magnetic field produced. Okay, as you observe, this is the point where the magnetic field we have to find out. Means amount of magnetic field produced due to this small element dl, okay, is nothing but what? The magnetic field produced here as a dP. Due to the small element dl, okay, the magnetic field produced at point O is what? dB. Understood? So again what we can say, this dl means small element of length dl and this one both are perpendicular to each other. As they are perpendicular to each other, then what we can say, as they are perpendicular to each other means they have an angle of 90 degree in between the dl and radius r. Okay, and what is this? This theta means in this formula, this theta is what? Angle in between small element dl and this one r. And so as you substitute the value of sine 90, sine theta as a sine 90, so what you have as a 1. Okay, you can see this step also here. So after that you get a formula simple as a dB is equal to mu 0 upon 4 pi into I dl divided by r square. Okay, then it's what? The magnetic field produced due to this small element only present at point A. Okay, and where it should be produced? At this point O. Means the magnetic field produced at point O due to only this small element dl. But what we have to find? We have to find the magnetic field due to the whole arc, and that's why what we have to do again, we have to find the magnetic field produced at this point due to this dl again, due to this dl again, and due to this dl, in this manner for all these dl's or small length elements. And so total magnetic field produced, that is B is equal to integral of dB. B is equal to integral of dB, and which can be given by integral of dB. Just mention the value of dB here, that is integral mu 0 upon 4 pi I dl divided by r square. Okay, now mu 0, 4 pi, current I, all these are the constant values. Even the r is also the constant for a given circle. And so what you can write here, simply I will show the calculation steps in the book. Okay, so what you can write here, the magnetic field produced at this point, it simply looks like this. Then integral of A to B, what is the limit from this end A to end B is the limit of given arc. Okay, then integral from A to B, okay, these remaining quantities are as it is. So integral of dl divided by r square. Okay, now as you take the value as you take an integral of this one, so what we have, the integral, as you solve this integral using the formula r x raised to n dx is equals to x raised to n plus 1 upon n plus 1. So according to that, as you solve it, what you have, it's a simple value, that is what, mu 0 upon 4 pi I divided by r into theta. Okay, where theta be the angle and which is in a radian. Okay, so in similar manner, okay, this is what about arc only, but as you are going to collect arc, or as you are going to add this one, so what happens, it completely becomes a circle. And so the magnetic field produced at the center of the full circle of wire carrying a current I. Listen, magnetic field produced at the center of the full circle of wire carrying current I. So that can be given by simply as a mu 0 I divided by 2 times r. Okay, means what the modifications in this formula, simply you just substitute theta is what, the value in a radians, and for a whole circle what is the value of theta, that is 2 pi. And so as you substitute here as a 2 pi, so what you have, this 2 pi get cancelled, only mu 0 I divided by 2 times r. Again one more step you can decide here. If suppose the wire is having a number of loops, then your formula becomes B is equal to mu 0 I divided by 2 times r multiplied by n be the number of turns. Okay, so in this manner, this is about what, magnetic field produced by a current in a circular arc of a wire. Okay, now the next topic is our 10.13, axial magnetic field produced by current in a circular loop. Okay, so what is the difference between the both topics? Simple one. Okay, in the previous lecture, means in the previous topic what we studied, we consider the circle and we find the magnetic field produced by arc at this center, either at the last, the formula we studied at the center of the circle. Okay, means exactly at where, at the center of a given circle. Okay, and now what we are going to study here, if suppose we consider that this is the current carrying circular coil, okay, which is observed by the side view. Okay, it is not the top view, it is a side view, and this is this line passing through the center of a given current carrying circular loop or wire. Okay, so in that case, what is the magnetic field produced on this axial point? Okay, line passing through center means what? It is the axis. And what is the magnetic field produced at any point? At any point due to the current carrying circular loop. And suppose I consider the point P is here, so how much the magnetic field produced at this point P due to this current carrying loop? That here we have to find out. Okay, understood the difference here in the previous topic and in this topic? In previous topic we simply found that, means that point where the magnetic field produced is in the plane of given circle or given circular loop. But now this point or this topic 10.13 is for what? It is not exactly in the plane, it is where, it is the point where the magnetic field produced, that point should be belongs along the axis of a given circular loop. Okay, means there is the basic difference between the both topics. Okay, now let us start with this topic. Now it's very simple. What we consider? We consider a current carrying circular loop. Okay. This current carrying circular loop carrying a current I through it. Okay. Let me consider that the current carrying circular loop here it should be shown you like this. Okay. Means what? As you plot a graph or observed by the graph, what you can say, it is in a xy plane. Okay, what is the plane of this circle? That is a xy. Okay, that shown you like here. Now I will just show you this figure like this. Okay, now what this figure tells us, your circle is present in the xy plane. Okay, current I be the flowing through this circular loop. We can see this is the direction of current flow through this loop. Let O be the center. Let theta be the angle. Just a minute. I will explain about the theta. Okay. Let I be the current flowing here, and this is xy plane. Now, what I can say here, if the circle or circular loop is present having radius capital R. What is the radius here? It is the capital R for this circular loop. Capital R be the radius of circular loop. Okay, so listen carefully, friends. Let this is a circular loop made up of wire present in a xy plane. Okay, then let O be the center of the circle. Current I is flowing in the anti-clockwise through the given circular coil. Okay, then what we have to find along the axis, we consider the point P. Okay, now if suppose as you observe this diagram, where its center should be here, and where is its axis? This axis belongs like this. Means we consider the point P here. Okay, for my convenience I will just shift it here. Okay, so this is a point P which is along the axis of a given circular coil. Okay, now in this case, means what? This is which axis? This axis is nothing but your z axis. Okay, it is what? Z axis. So let this point P is joined by this one. Let me consider this point at Y and join this one like this. So it makes an angle theta. Okay, what is a theta? Theta be the angle made by the line joining the point P and a circular loop. Okay, now in this case, this axis means axis of a given circle where the point P is present, where we have to find the magnetic field, is present where? Along the z axis. Means x, y, z are mutually perpendicular to each other. That is a clear thing. Okay, then now we have to apply here Bioware Cyber Law. Okay, for obtaining the magnitude of magnetic field produced at point P. Okay, at point P the magnitude of magnetic field is produced. Okay, and to find it, what we have to do? Simple, we have to distribute this circle or circular loop into a small elements, each of length dl. What we have to do? We have to distribute it into a small pieces, each of element of length dl. Okay, and so as you divide it into the small elements of length dl, then what is the next? Now after that, we consider the small element present here. Suppose, okay, I will say it as a, or I will suggest you the name as a. Okay, now what you can say, this element of length dl, okay, which is simply look like an arc as you observe. Okay, simply you can observe here, it's a part like a arc. Okay, but what is the difference there? that is a vertical section. Okay, and so you can't say exactly as an arc. Okay, I just say here this is what dl be nothing but the small element of length r, and so it is simply like a arc. This dl and this particular r, okay, means distance, these both are what, like this, so they makes an angle 90 degree here. Okay, is that clear? Simple. What I am saying, as shown in this figure, okay, what we can say, you have to just first clear your concept. What is that? The small element dl and this line joining r makes the angle theta, which is nothing but the 90 degree. As you move here also, or as you consider the exactly opposite element again for this one, this angle should be the 90 degree. In similar manner, for anyone, for each and every dl present on this circular loop, for that the line joining both should be what? Should be the simply as a 90 degree. Okay, so that line joining makes the angle simply as a 90 degree with the small element dl. Okay, now you have to apply the Bioware Cyber Law. To apply the Bioware Cyber Law, okay, what we have now here, the formula is given to you like this, okay, but which is makes some complications here. I'll suggest you a simple formula what you have to use, because the words you are given, the magnitude of magnetic field induction, okay, dB is given by, so dB is equal to, no need to write this formula, you can simply write mu 0, because magnitude we have to consider, ideal sine theta divided by r square, and this is your 4 pi. Okay, simply as we seen here, the dl and this length means this theta should be the 90 degree. As it is a 90 degree, so what we can say, as this 90 degree, so it will becomes 1. Okay, means what's the remaining? Mu 0 divided by 4 pi I dl divided by r square. You got your final formula. Okay, and a difficulty? Okay, simple. What we do or we take consider directly as a magnitude of a given magnetic field at a given point, and just we will do consideration of the angle theta as 90 degree. We will get the final formula, means it will be save your time for writing all these things. Okay, you just write the directly formula and just mention the simple sentence, the dl makes an angle theta. Okay, dl and r makes an angle theta, which is a 90 degree in a given case. Okay, now by substituting the value of r square, what is the value of r square? As from this figure, what we can say, this is your r be the distance, z be the distance of point P, okay, from center O. Okay, remember point P is situated at a distance Z from center O. Okay, and now what we have to find? We have to find out the value of R. Okay, and this is the radius of circle. According to the Pythagoras theorem, what we have? According to the Pythagoras theorem, we can say that R square is equal to Z square plus r square, and by substituting this value in the given relation, what we can say, the value of this dB should be the mu 0 upon 4 pi I into dl z square plus r square. Okay, then in the next case, okay, understood this formula? The next step is what? So when you consider this figure, okay, like this, in that case, what we can say, this is a small element of length dl. Okay, this is your now in that case, this is your r, this is your z, and this is your capital R. This is angle theta. This is a point P. Okay. Now everyone know that you have to remember always what is that the direction of magnetic field produced according to the Bioware Cyber Law, the direction of magnetic field produced which is always perpendicular to both the line joining as well as the small element dl. Okay, means it is a perpendicular to both line joining as well as the length of the small element. Okay, means it is a perpendicular to both, so its direction like this. As you resolve it into the perpendicular components, if you resolve this dv into its perpendicular components, okay, so this is a perpendicular components which is called simple, which is a perpendicular to the z axis. Okay, means I will wrote it as a dvz. I will write it as a dbz, db perpendicular. Okay, db perpendicular. You can see the diagram in your book. Okay, simply looks like this. Now what we can say, this is nothing but your perpendicular component to the z axis, and this component is parallel to the z axis, and so it is represented by simply as a dbz. Okay. After that but what is the matter here, this perpendicular component db perpendicular, what happens with it? If suppose I will take exactly other opposite element like this, so again for that again the two complements, means two components are exactly the same here. Okay, means every case of the dl for every small element on this circle, what we can say, everywhere there should be the perpendicular element of db to the z axis is equal and opposite, and so basically what happens, the sum of all these one becomes 0, because these forces are what, means magnetic field is what, equal and opposite, and in this manner what happens, they cancels each other, means which component is remains only, the component which is a parallel to the z axis, that is dbz is remains in each case, and so total magnetic field produced at point P is due to only what, is due to only the parallel components of z axis. Okay, only due to the parallel component of z axis, and so what we can write, total magnetic field produced dbz is equal to db cos theta. Now the question is that from where this db cos theta comes. Okay, so db, everyone know that as this angle is theta, so this angle is theta according to the geometry. Okay, and so what happens, everyone know that this component which is closer to the angle is always represented as a cos by vector. Okay, and this is your what, db sin theta. This dv sin theta get cancels everywhere in all possible directions, and so what happens, only db cos theta get added together, and finally what we can say, the total magnetic field produced at point P, that is the magnetic field along the z axis, can be given by integral of dbz by substituting the values of dbz. Okay, and now you know that the value of dbz as what, mu 0 upon 4 pi I into dl z square plus r square, bracket complete. Okay, but again the one more question is there, as from this formula what we can say, the value of, okay, dbz as a db cos theta. Okay, what is a dbz? As a db cos theta, means it can be written as a db cos theta. So you should substitute the value of db, and now this is a cos theta. Okay, I will show you in a book page simply like this. Okay, now look here, According to that, bz is equals to integration of dbz. Okay, so mu 0 upon 4 pi remains as it is because we have a formula. Okay, dbz is what? db cos theta. dbz is what? That is a db cos theta. And so therefore, what is that? Here dbz can be written as a db cos theta. This is the value of db and this is cos theta separately. Okay, I will show where is the value of db. Here you can see what is the value of db, that is a mu 0 upon 4 pi. You can look here, I into dl divided by z square plus r square, bracket complete, and the cos theta remains outside. Okay, now up to that, by substituting this value here, then what about the cos theta? For a cos theta, simply again what we can say, this is your z, this is your r, and this is your capital R. So cos theta can be given by simply as a cos theta is equal to, okay, what is the formula? That is the adjacent side divided by hypotenuse. Okay, capital R divided by small r. What is a small r? As per the formula of Pythagoras theorem, what we can write, the value of value of r as under root of z square plus r square. By substituting these values in the given relation, what we get? We get a simple relation. What? Okay, cos theta's value should be like this, r divided by under root of z square plus r square. Now this square root and this means what? This raised to power 1, suppose x raised to power 1, okay, and another one x raised to power half. Square root means what? Half of the power. Okay, means x raised to 1 by 2. So it will becomes 3 by 2, and so the value should be your 3 by 2. Okay, then again by simply integration of r dl is simply what? Integration of dl substituted as a 2 pi r. What is that? Circumference of a given circular loop, and so the value should be 2 pi r. And by putting all this value, finally we get the formula as a bz is equals to mu 0 divided by 2 I r square divided by z square plus r square raised to 3 by 2. Okay, and so this is what the magnitude of magnetic field due to current I in the loop of radius capital R on a point at P on the z axis of the loop. Okay, it's somewhat complicated to say, but simply what you can say, you just remember to say like this. This is the magnetic field produced at a point along the axis of a current carrying circular coil. Okay, I will show you the one more figure to clear this concept. Okay, you can see this figure, and as from this figure, and from this figure what you can say, okay, this is a current carrying circular loop, this is the axis, this is the point P, this is the line joining, okay, and this is the magnetic field dB, its perpendicular component, its parallel component to the z axis. Simple. Okay, and this figure simplifies you this topic. Okay, I hope you understood better. If you have any doubt related to this topic, you can ask me into the comment section. Okay, thank you for watching video.